Welcome to our discussions and thank you for always joining us. We are looking at Booker Academy Chemistry Examinations Form 2. And the question we have reads, name the apparatus, name two apparatus that can be used for determining accurate volumes in the laboratory. For the apparatus used for measuring volumes, there are those that are used to measure approximate volumes and those that are used to measure accurate volumes. For those that we use to measure accurate volumes include the burette, we have the burette. We can also use a pipette. We can as well use a measuring cylinder. Any of those can be used to measure the exact or accurate volumes. B, state two disadvantages of using a luminous flame. Remember we talked about two types of flames produced by a Bunsen burner. One is a non-luminous, and two, we have a luminous flame. One of the advantages of using a luminous flame is that it produces soot. It produces soot, or what we call smoke, which makes the apparatus dirty. Apart from that, it produces less heat. We go to question number 2. State reasons why most laboratory apparatus are made up of glass. One, we say glass apparatus do not react with laboratory reagents or reactants. Number 2, glass is transparent. Glass is transparent. Glass is transparent for easy visibility. So one can easily monitor as reactions take place. And number 3, glass is easy to clean. Glass apparatus are easy to clean. Those are the 3 reasons behind glass apparatus. 3, name 2 substances formed when a candle burns in air. Remember, a candle is probably candle wax is organic in nature, and therefore when organic substances burn in air, they produce 2 substances. One is carbon 4 oxide. Carbon 4 oxide. And number 2, water. We can as well represent them using their chemical symbols as follows. We go to question number 4. The following setup was used to investigate the products formed when candle burns. Remember, when candle burns, it produces carbon 4 oxide and water. So in this setup, we have the inverted funnel for directing the substances formed by the burning candle into tube A all the way to test tube B. We have the ice cold water and also calcium hydroxide solution in test tube B. State the observations made in test tube A. Remember, when candle burns, it produces carbon 4 oxide and also water. So water comes to test tube A, where it condenses into the colorless liquid. That means what is coming to be cooled is water vapor. So in A, you expect a colorless liquid. You expect a colorless liquid. Then we have B. Test tube B, we have carbon 4 oxide, which does not get cooled by the ice cold water. So it crosses over to B, where it reacts with calcium hydroxide to form a white precipitate. White precipitate is formed. Then we move down. Explain the observations you stated in A Roman 1 and Roman 2 above. In Roman 1, water vapor from the burning candle is cooled into water, into a colorless liquid by ice cold water. Then in 2, carbon 4 oxide, of course from the burning candle, reacts with calcium hydroxide. Let me use the symbols because of the space. Reacts with calcium hydroxide to form a white precipitate of calcium carbonate. We move to part D. Give one physical test for the components of test tube A. Test tube A has water, and therefore the physical test for water is determining its boiling points. Determining the boiling points. And we know pure water boils at 100 degrees above sea level. We go to another question that follows. State a reason why aluminum is a better conductor of heat and electricity compared to sodium and magnesium. Remember, sodium is a metal in atomic number 11 with an electron arrangement of 281. We have magnesium in atomic number 12 with 282, and aluminum in number 13 with 283. The electrons in the outermost energy level are delocalized, and they are used to conduct electricity. The one that has more delocalized electrons becomes a better conductor, and therefore we say aluminium has more delocalized electrons than magnesium and sodium. Hence, a better conductor. B, in terms of structure and bonding, explain why graphite conducts electricity, but diamond is a non-conductor. We know during structure and bonding, graphite uses only 3 of its valence electrons to form bond or in bond formation. Therefore, we have one electron not used, or the extra electron is used to conduct electricity. You see, diamond is a non-conductor because it uses all its electrons in bond formation. We move down to question number 5. Question number 5 reads, the setup in the figure below was used to investigate some property of oxygen. Remember, oxygen is a reducing agent, and therefore the property in a nutshell is reducing property or simply reduction. We have dry hydrogen that goes to react with copper 2 oxide, but remember copper 2 oxide must be heated, and therefore one of the conditions missing here is heat. We move down. Hydrogen gas is allowed to pass through the test tube for some time before it is lit. Explain. Explain why hydrogen is allowed to pass through the combustion tube. So the reason behind that is to ensure hydrogen being burnt that hydrogen being burnt at the jet is pure, to avoid explosion. We move down. Write an equation for the reaction that occurs in the combustion tube. Remember, we have hydrogen gas reacting with copper 2 oxide, and hydrogen being more reactive than copper or being higher in the reactivity series, we remove the combined oxygen from copper such that we have copper metal, and of course hydrogen is oxidized to water, which is a liquid. The equation is automatically balanced. When the reaction is complete, hydrogen gas is passed through the apparatus until they cool. Explain. This is so to prevent the oxidation of the hot copper metal. So this is to prevent reoxidation of copper metal by oxygen. Then Number 5, what property of hydrogen is being investigated? You can see hydrogen acting as a reducing agent, and therefore we can either say reducing properties of hydrogen, or we can as well talk about reduction. Question number 6. State 2 conditions necessary for rusting to occur. Rusting occurs because of the presence of oxygen and also water. Whenever oxygen and water are present, then iron will rust. How is the rusting process accelerated in our daily life? So we look at those factors that speed up the process of rusting, and therefore it is accelerated by the presence by the presence of acidic or high salt concentrations. However, we can as well argue and say, remember we have those factories that emit gases. Factories emit gases such as sulfur 4 oxide, nitrogen 4 oxide. Let me use the symbols because of the space, which mix with rainwater to form acid rain, which corrodes iron equipments. The presence of also high salt concentrations will actually cause rusting. State 4 ways that can be used to prevent rusting. 1 is painting. 2, we can use coating with other metals. And this can be done through either galvanization or what we call electroplating. 3, we can use sacrificial protection. We also have alloying. We have sacrificial protection. Apart from sacrificial protection, we have oiling and greasing. Quite a number of them. Remember to subscribe to the channel and also help us to share the link. The setup below, that is part D, was used in an experiment to determine the conditions necessary for rusting. We have setup A that has distilled water and the nails, B, boiled and cooled water, but we have the nails and a layer of oil, stroke the stopper that prevents the entry of oxygen into the water. In setup 3, that is C, we have anhydrous calcium chloride that is used to absorb moisture. We have the cotton wool, which prevents again the moisture from coming into the nails and of course the stopper there. you expect the nails in setup A to rust. So the question is, in which setup will the iron nails rust? Explain. Of course, that is setup A. Why? If you look at setup A, distilled water contains oxygen, and of course water is there, and therefore we can say both water and oxygen are present. Those two are the conditions necessary for rusting to take place. We move to question number 7. In question number 7, study the table below. The letters do not represent the actual symbols of elements. We have A in atomic number 3, and therefore we are going to have an electron arrangement of 2, 1. We have B in atomic number 13 with 2, 8, 1. We have C, 2, 8, 6. D, 2, 8, 8. And E, 2, 8, 8, 1. Part A, select the element which belong to the same group. Remember elements that belong to the same group. Sorry, this is 3. This is 2, 8, 3, because it's atomic number 13. Elements that belong to the same group have the same electrons in the outermost energy level, and therefore A and E are found in the same group, and to be more precise, they are found in group 1. Same period, they must have the same number of occupied energy levels, and if you look at A, that is, if you look at B, C, and D, they all have 3 occupied energy levels, and therefore they belong to the same period, which is period 3. So the elements will be B, C, and D. Reason they have same number of occupied energy levels. B, which element is gaseous at room temperature? Explain taking room temperature as 25 degrees Celsius. Remember, if we convert this temperature into kelvins, we are going to take 25. We add 273. So in absolute scale, we are going to have 298 kelvins. And if you look at the boiling points, which are given here, the one that is below 298 is element D at 87 kelvins, and therefore we say it is element D. Reason, its boiling point is below 298 kelvins, or simply 25 degrees Celsius. We move down. Roman 2 does not form an oxide again, it is element D. Reason, if you look at element D, you realize it has a stable electron arrangement, and therefore it doesn't lose or gain electrons. And if an element does not lose or gain, therefore it is stable and it's unreactive. So we say it has a stable electron arrangement. It has a stable electron configuration. Or simply arrangement. C, write the formula of the nitrate of E. E is in atomic number 19 with an electron arrangement of 2881. So it has a valency of 1, and a nitrate ion has a valency of 1, and therefore we are going to have E, NO3. Roman 2 write an equation for the reaction between element B and oxygen. Let us go and look at element B. Element B is in atomic number 13. B is in atomic number 13 with 283. The valence is very important. Oxygen is in atomic number 8 with 26. So the valency of oxygen is 2. That will assist us in writing a correct chemical equation. So we are going to have B being a metal plus oxygen, which is a gas. Here we are going to have B oxide. The valency of oxygen is 2, it goes to B, and that of B is 3, it goes to oxygen. This is a metallic oxide, and metallic oxides are solids at room temperature. To balance the equation, we write 2 behind B oxide so that the oxygens are 6. To balance the oxygens, we write 3 behind oxygen, and of course, the B's will be 4, and therefore we multiply B by 4 on the reactant side. That equation is now automatically balanced. We move to question number 8. The diagram below shows methods for collecting gases in the laboratory. We have A, which is downward delivery, and also B, which is over water collection. So A is known as downward delivery, or we can as well say it is upward displacement of air. Reason being, these gases are denser than air, and therefore air moves upwards as they settle on the bottom. Then B, we talk about over water collection, and gases collected using the approach in B are insoluble in water. State the property of gases that allows them to be collected by method A. The property is density, and therefore we say they are denser than air. We move to the next question, where we have question number 9. Question number 9 is on structure and bonding. Using X and dots to represent electrons, show bonding in the following compounds. We have sodium chloride. Remember, sodium is in atomic number 11 with 281. We also have chlorine in atomic number 17 with 287. So sodium will lose 1 electron, which will be gained by chlorine in order to be stable. So what we are going to do, we can start by drawing sodium. The structure of sodium, we have 8 electrons, then 1 electron in the outermost energy level. This reacting with chlorine. Chlorine, we can draw the center. Then the first energy level has 2 electrons. The second one has 8. The third one has 7 electrons. So we are using dots. So here we have 1. So we expect this one to come here. So on this other side, we are going to have sodium ion with 2, 8, and of course the chloride ion with 2, 8, 8. So we are going to draw the sodium ion with 2, then 8. So this is an ion, we put it under square brackets and indicate the charge on it. Then we are going also to have the chloride ion with 1, 2. We are going to have eight. Then finally 8. These are 6. Then 7, 8 here. Again, this is an ion. We put it under square bracket and indicate the net or the charge on it. We have ammonium ion. We are going to have nitrogen bonding with 4 hydrogen atoms. So remember, nitrogen is in atomic number 7 with 2, 5. Therefore, hydrogen is in atomic number 1 with only 1 electron. So we are going to have hydrogen, 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 hydrogen here. Remember, hydrogen will have 1. Then nitrogen will place 1 here. Hydrogen has 1. Nitrogen will place 1. And of course, hydrogen has 1. Nitrogen will add 1. So we have removed 3 valence electrons from nitrogen. One of the nitrogens is always empty, and therefore it receives the 2 electrons from nitrogen, so that both of them are satisfied. And in this case, the net charge on the ammonium ion will be positive. Then we have potassium chloride, which is done the same way sodium chloride is done. So we are going to have to draw the structure of the potassium ion. It will have 1, 2, then 8, then 8, that is after losing 1, because it will be 2, 8, 8, 1. So after losing 1, we are going to have a positively charged ion of potassium. The net charge is positive. And of course, chlorine will have 2, 8, 7. So it will get 1 from potassium. So for chlorine, we are going to have 1, 2. We close. Then we have 8. In the second energy level. Then lastly, we are going to have 8. So 1 will come from potassium. So this one will be, the charge is negative. So that is how we show bonding in potassium chloride, ammonium chloride, and sodium chloride. We move to question number 10. We move to question number 10. Explain why the boiling point of ethanol is 78 degrees Celsius, while that of dimethyl ether is 0 degrees, although they have the same molecular mass. This is because ethanol has the hydroxyl part that forms the strong hydrogen bond, but dimethyl ether does not have that hydrogen or hydroxide part, and therefore we can say ethanol has hydrogen bonds, has strong hydrogen bonds, due to the hydroxyl group. Which are stronger than intermolecular forces or bonds in dimethyl ether. We will continue revising this paper until the end of it. Thank you for watching and welcome to the discussion. And in case you are watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we produce a video like this, you will automatically be given a notification. Thank you and welcome.